This video is on physical and chemical properties. Physical properties are properties that can be measured without changing the identity of the substance. So think of a property as a characteristic, like a descriptor of an object or something that you have there maybe in the lab. So these are properties or characteristics that you can measure them. The identity of the substance doesn't change. So examples are like color. That's a very easy, obvious first descriptor or property would be the color of something or the size of something. Luster is how shiny something is. So that's a good thing to make note of if you didn't know what that meant. Right? How something smells, and then the temperature it melts or boils at. So melting point, in the last video, it was talked about what melting was. That's a solid, right? Turning into a liquid. So melting point is the temperature that happens at. Or it's also the same as the freezing point. Because what's happening at the freezing point, come back, there we go. What's happening at the freezing point is the opposite of melting. Freezing is just a liquid, right? Turning into a solid. So it's just the opposite direction, but it's the same temperature where that change happens. Boiling point is the same idea. Boiling is when you have a liquid and it's turning into a gas. The condensation point would be the reverse, a gas turning into a liquid, condensing. Okay, so these are all things that happen, or you can describe them or characterize them, and they don't change what it is. Like if I have a piece of metal and I say like, well, it's a gray color. Okay, well, that's going to help me narrow it down. It's just going to describe what it looks like. Or it's 52 grams because I put it on the balance. That's the size. Or it's not shiny at all. It's dull. Okay, that's describing its luster. Maybe it doesn't have a smell. Maybe it's a solid and I put it in a beaker and I get it hot enough and I figure out what temperature it melts at. Okay, those are all what we call physical properties. All right. Now, physical properties can be split up into two groups. There are intensive physical properties and extensive physical properties. Intensive physical properties don't depend on the size of the sample. What I always think of to help me remember this is intensive starts with an I. These help you identify a substance, okay? So they don't depend on how much you have. They are always going to be true. So example here, it says, no matter how much pure copper you have, it always has the same distinctive color. You know the color of copper, it's pennies. That color is copper. Whether you have a huge brick of copper or a little teeny chunk of a penny, copper is the same color. So we just talked about color being a physical property. It's an intensive physical property, regardless of how much I have, and it would help me identify it. Water, freezing point. Water freezes at 0 Celsius. So if I have a bathtub of water or a little teeny tablespoon of water, it's going to freeze at 0 degrees Celsius. It's going to take different amounts of time, but the temperature when it happens, if you stick a thermometer in there, that temperature will say 0 for all amounts, okay? Which will also help you identify it because water, that's specific to water. All right, so some common intensive properties are density. Density is unique to each substance. You can look things up and you can just Google the density of aluminum and you can find that value. Freezing point, color, melting point, luster. There's actually like measurements for how shiny or dull it is. Malleability, so how much you can manipulate its shape. So malleability is like ability to mold the shape. The temperature, and conductivity, so how well it conducts electricity. So these are intensive, help you identify it. No matter how much or how little you have, these are true. Extensive does depend on the size. Okay, so these are going to be things like a length, a volume, a mass, a weight. If I tell you an object is 23 centimeters long, that doesn't tell you at all what it is. If I tell you the object is 23 centimeters long, but it's a coppery kind of goldish color, okay, now I'm starting to get more when I get that intensive property. Extensive properties just depend on the size. I could have a copper piece that's 52 centimeters, or I could have a copper piece that's, I don't know, 73 kilometers. If I just tell you the extensive property, right, it doesn't help you identify it. Okay, that's the size, the amount that you have. Okay, so these are all physical properties. So chemical properties are different. Chemical properties are, this relates to the ability of a substance to undergo a change that changes its identity. So changing an identity is a chemical change. Physical change is not changing the identity. You can only see this in a chemical reaction. So these are harder to identify just by looking at something. You have to know more information, or you have to try the reaction. So, for example, things that are flammable. So like if I have a jug of isopropyl alcohol, it'll have a big warning sign that'll say flammable. That's a chemical property of that. I would only know that if the label told me, or if I tried to light it on fire. If something resists corrosion or actually corrodes, that's kind of like how it breaks down. Rusting, tarnishing, these are all chemical reactions, chemical changes. So things that do them or don't do them, that's a physical property of them. Like if you have a certain metal, certain metals like iron will rust. But then let's say you have stainless steel and it's coated, you could say that resists rusting, okay, or it won't rust. Those are both chemical properties, whether it does or it doesn't. All right, so this was chemical and physical properties. Be careful with the intensive and extensive physical properties.